All right, let's get right into it. We all know large language models are these amazing generalists, right? They can write a poem, they can write code, they can even try to explain quantum physics. But here's the paradox. Getting them to be true experts at a specific, real-world job, well, that's incredibly hard, it's slow, and it is ridiculously expensive.
So that leads us to the big question we're tackling today. If you have an AI that's already really smart, how do you teach it a new, specialized skill, like becoming a math whiz or an expert web researcher, without basically having to do a full brain transplant every single time?
So, here's our roadmap. We're going to look at the huge cost of teaching AI, then talk about the old method, which we're calling brain surgery. After that, we'll introduce a brand new idea, the playbook. We'll see how an AI can actually teach itself, look at the absolutely mind-blowing results, and finally talk about what this means for all of us.
Okay, so here's the core issue. LLMs are great with general knowledge, but the second you put them in a specialized field, their performance just tanks. We're talking about areas that need specific tools, like a code interpreter, or really unique strategies. The out-of-the-box models just don't know the rules of the game.
Now, the way we've traditionally tried to fix this is a process called fine-tuning. And I want you to think of this as performing complex brain surgery on the AI. Seriously, you're literally going in and messing with its core neural network, changing its fundamental wiring to force it to learn a new trick. And you can probably guess that's super risky and incredibly intensive. And this slide just lays it out perfectly. On the left, you've got the parameter space. That's the AI's brain. That's the messy, expensive surgery we're talking about. But on the right, you have the context space. That's the AI's playbook. It's the difference between trying to rewire a brain and just handing someone a better set of instructions. So much simpler.
And yeah, this brain surgery approach has a ton of problems. First, it costs a fortune in computing power. We're talking thousands and thousands of dollars. Second, the model gets so specialized that it actually forgets how to do other things. Plus, you need mountains of really high-quality data, which is super hard to find. It's a massive bottleneck.
So, if brain surgery is off the table, what's the alternative? Well, this is where it gets exciting. Researchers came up with this brilliant method called training-free group relative policy optimization, or let's just call it TFGRPO. Instead of operating on the brain, it works entirely in that context space. It's all about creating the perfect playbook.
And this quote from the paper just nails the big idea here. The key insight is that these LLMs don't need surgery. They just need practice. You can teach them by giving them what the paper calls experiential knowledge. From a tiny, tiny data set, letting them learn from trying things out, just like we do.
So what exactly is this experiential knowledge? You can think of it as a library of golden nuggets. These are distilled insights and winning strategies that the AI figures out by itself, just by trying and seeing what works. This library becomes its go-to playbook, a smart guide it can check to make better decisions next time. And this leads to the really clever part. How does the AI actually build this playbook? Well, it uses this simple, elegant learning loop that requires zero, and I mean zero, costly retraining. It all happens on the fly.
Here's how it works in 4 simple steps. First, the AI tries a bunch of different ways to solve a problem. Then, step 2, it looks back at its own attempts and figures out which ones were winners and which were losers. Third, and this is the magic right here, it learns why. It actually writes down a little note to itself, a semantic advantage, explaining the strategy that worked. Finally, it remembers that insight, updating its playbook with the new rule.
And this isn't a one-time thing. The AI runs through this loop over and over again on a small set of practice problems. And with every single cycle, its playbook gets smarter, more strategic, and more effective. It is literally practicing and improving itself.
Okay, so the theory sounds amazing, right? It's elegant. But does it actually work in the real world? Well, this is where the story gets really, really good. Let's look at the proof.
So the researchers tested this on some seriously tough math problems. The standard model, the baseline, did okay. It scored 80% on one test and about 68% on another. But after applying this new playbook method, its score jumped by almost 3 points on one and a massive 5.4 points on the other. That is a huge leap on a task that needs really complex thinking. But this is the slide that's going to blow your mind. The cost. The old way, traditional fine-tuning, can cost over $10,000 to do this.
The cost for this entire new learning process? About $18. No, I'm not kidding. 18.
Let's just let that sink in for a second. This new way of teaching in AI is over 500 times cheaper. It completely changes the economics of creating specialized AI. It's a total game changer.
And it's not just about being cheap. This method is also incredibly efficient with data, needing only about 100 examples instead of thousands. The AI's core knowledge isn't touched, so it doesn't forget its other skills. You just swap in a new playbook for a new task. And it's versatile too. It showed similar big gains on things like complex web searching.
So what's the big picture here? What does all this actually mean? Let's zoom out for a second, because this is about way more than just a clever new technique. This is the key takeaway. This innovation basically democratizes expert AI. Building a powerful, specialized AI is no longer something that only huge companies with giant budgets can do. It makes it accessible, efficient, and truly practical for solving all kinds of problems out there in the real world.
You know, the paper's own conclusion says it perfectly. This isn't just a small improvement. It's a new, highly efficient pathway. It's about taking these incredible AI capabilities and making them something that way more people can actually build and use. It's a fundamental shift from expensive surgery to affordable, effective schooling.
Which leaves us with a really fascinating question to think about. For so long, the biggest limit on AI wasn't just what it could do, but what we could afford to teach it to do. Now that teaching an AI to be an expert is this easy and this cheap, what should we have them do? What big problems should we point them at? I would love to hear what you think in the comments.